I'm Sophie Collier and I'm a structural engineer at Elliott Wood, and I'm going to kind of continue the conversation about designing for reuse. So my presentation is going to focus on design for reuse, but before delving into that, I kind of wanted to zoom out for a second and look at the kind of wider key principles of designing sustainable buildings. So I think three of the kind of key underlying principles of sustainable building design that structural engineers have to think about all the time are, firstly, limiting embodied carbon in the buildings you're designing, designing to use resources as efficiently as possible. Secondly, designing buildings to be flexible so that they can adapt over time and hopefully continue to meet the societal need for as long as possible. And then sort of after those considerations comes the consideration of designing for disassembly and reuse at the end of the structure's life. And I think all three of these principles are really important in sort of achieving the aims of the circular economy, of minimizing virgin material consumption. But I think within the climate crisis, it's really important to remember that we're running out of time. So limiting embodied carbon has a very immediate impact, because any material that you can save now saves the embodied carbon of that material. I think designing for flexibility and adaptability has more of a medium-term impact, because you start to see the benefits of that when a building after sort of 30 or 40 years, say, is not knocked down and instead is adapted to continue its lifespan. And I think with design for disassembly and reuse, for new builds, you only really start to feel the benefit of that after sort of 60 or 100 years or whatever the design life or useful design life of the new structure that you're designing. And so I think whilst being able to disassemble buildings in the future is really important, in the immediate term, what we're working with is a building stock that hasn't been designed for disassembly. So I think that the first question we kind of need to ask ourselves is, how can we disassemble buildings that already exist that haven't been designed for disassembly? So the first case study I kind of want to focus in on was a steel reuse project that we're working on currently at Elliott Wood, which is essentially, we're on site at the moment, taking apart an existing steel building, going through the process of working out what's there, recovering the steel, testing and defabrication, and then we will be going into refabrication and reuse in a new development. And I think the reason I wanted to run through this is because I think from that we've learned a huge amount about how we can actually best design new buildings so that the engineers of the future have a bit of an easier ride of it. So I think some of the key lessons learned I wanted to run through were that supply chain storage and program is currently a much bigger barrier to reuse than the deconstruction process itself. So I think, often reuse guides around designing for reuse really focus on the sort of nuts and bolts of taking apart existing structures. But in a way, the priority has to be creating societal structures within our sort of cities, systems that can enable these kinds of processes to happen. And I think that will get easier and easier the more people are doing this. Secondly, viability of reuse, both financially and from a sustainability perspective, is really dependent on maximizing the efficiency of the deconstruction process and minimizing waste. So allowing deconstruction to happen as fast as possible. And I think, one of the really interesting things that's come out of that is that in reuse of steel, people have discovered that hot cutting out the existing beams is a lot quicker than unbolting each individual one. So I think, again, a lot of early reuse guides really focused in on making sure that every connection is demountable. All of the connecting pieces are stainless, so that you're going to be able to unbolt beams at the end of life. But I think through practical experience of doing this on site, with steel beams, it's really been found that there are often more efficient ways of doing things that aren't necessarily what we would initially have thought. So moving on from that, another thing we found is that existing building information is absolutely invaluable. So I'm going to talk a bit later a bit more about material passports, but I think as much information that we can give to future engineers about what's in a building as possible will make their lives a huge amount easier in trying to work out what they can reuse in the future. And finally, just a point about simplicity of load paths and sort of rationalization of the structure. We found that, especially from a sort of safety perspective and simplicity of the actual deconstruction sequence, having a load path that is really obvious to see has huge benefits from that kind of a perspective. So yeah, I think all of those sort of lessons learned can really feed into the question of how can we design new structures to be reused in a better way. But the kind of flip side of how do we reuse existing structures, and another way that we can bring some of the benefits of reuse into the sort of present day, is thinking about how can we construct new structures out of waste products or pieces of existing buildings. And quite a fun case study I wanted to run you through on that was the Glyndebourne Pavilion, which is an interesting project I've been involved in designing the structure for, where we've been looking at trying to source as much of the building fabric as possible from within 5 miles of the site, and all being sort of waste products that otherwise would have been downcycled or gone to landfill. So the very first step of this was to ask the question, what materials are available? And obviously this is quite a unique kind of site and unique kind of setting, but for us that happened to be that there were a load of ash trees that were being felled locally due to ash dieback, that otherwise would have been sort of chipped up and devalued. So that became one of our main structural elements. Also, the Glyndebourne estate is home to the an opera festival every summer, which has a lot of waste products that come out of it, including champagne corks, oyster and lobster shells, and food waste from the festival goers. And we sort of looked at trying to find ways of using as much of these waste materials that were available, and turning them into useful structural elements. So we had a lot of fun with local work studio, who made these amazing sort of waste-based cast features out of crushed lobster shells from the festival, amongst other things, which was definitely very, very interesting and fun. But this, from a structural perspective, we had a real challenge because the Eurocodes don't currently cover ash. So what we had to do was sort of work closely with Braden Timber Structures to use kind of CP 112, so the last code that covered ash, to create a methodology of visual grading that would allow us to design ash glulam that was sort of compliant with modern codes. So all of this to say, that's quite a unique and unusual project. But I think what I'm trying to get across is a shift in mindset from, instead of thinking this is the design that I want to build and how am I going to source the materials for it, instead shifting that around to what materials are available and then what can I do with them. And I think although this is a very unique setting, the same principle applies from a sort of urban mining perspective, or when you're working with an existing steel stock list. It's flipping the question and sometimes having to be quite creative with what you have, to create something that will meet the societal need. So this structure was designed for disassembly, and what I've got up on screen now is kind of a summary of some of the key tools that we applied on this project, to enable it to be easily demountable at end of life. So some of them are certainly easy wins that I think should be applied on as many sort of new project as possible. Others are not necessarily applicable in all projects, but just to focus in on a few of them. As I mentioned previously, simplicity of structural form is a really key one. So I know architects will hate us for saying it and will often want crazy cantilevers and transfers, but we really wanted on this project the load paths to be immediately accessible, and sort of clear, so that the engineers and contractors of the future could immediately see what was going on and just demount it in a safe way. Secondly, building in layers was another really key one. So although from my point at the start about only sort of feeling the gains of designing for disassembly after sort of 60 or 100 years or the life of the building. In fact, the lifespan of the M&E and internal finishes and partitions is often significantly less than that. So if we can create buildings where those internal layers can be replaced on a different frequency to replacement of the whole building, that can massively improve your sustainability of your structure. So we had our M&E and finishes on sort of separate layers, separate from the structure, so that they could be changed in future without needing to make structural alterations. Another one I want to mention quickly is avoiding toxic treatments and coatings, because there are certainly certain materials where there's a legal obligation to dispose of them in a very particular and non-reusable way at end of life if they contain certain toxic treatments. So yeah, I think do research those and make sure that you avoid them as much as humanly possible. And the final one I just wanted to run through was material passports. So on this project, we decided to make quite a feature of it because they wanted the reuse to really be part of the experience of the users of the building. So we had sort of QR codes going up on all the structural elements that people could scan with their phones, and would include sort of all of the relevant material and structural information about each element. But the point being, as I mentioned before, as much information as possible to be made available for the engineers in the future to know what they're dealing with. So to wrap that all together, really, I think the main point that I'm trying to make is that design for disassembly is a really amazing tool, but I think reuse of buildings reaching the end of their lives now kind of has to be the priority. And I think from that we will learn a huge amount about how to design for disassembly in a better way in the future. And yeah, while it's a really valuable tool, I think it's really important to keep the bigger picture in view. So this kind of flow chart is kind of based on the sort of use less stuff hierarchy, and thinking through the kind of questions that we need to ask first before we get to the point where we're asking how we can design for disassembly. And I think the place we have to start, as is repeated time and time again, is, do we need this development? And that kind of has to be the starting point from a sustainability perspective. And then moving on to, is reuse or refurbishment an option? Can we, if it is going to be new build, can we use reclaimed or sustainably sourced materials? And then moving into, how can we achieve the highest possible efficiency? How can we increase adaptability without significantly increasing material use? And then finally, what design for disassembly tools can we apply to this? And yeah, I think that as I mentioned as well, there are definitely some easy wins with design for disassembly, and I think we should take those whenever we possibly can. But yeah, there is also a lot to learn, and I think we will continue to learn the more that we disassemble the buildings that we have available to us now. So yeah, just a final slide with a few resources to look out for. In particular, the iStruct Circular Economy and Reuse Guidance for Designers is coming out in May, and the Glyndebourne Pavilion is one of the case studies that's looked at